Howdy, howdy, y'all. Welcome back to Some Antics. This Tuesday, I am joined by Austin Crim. Austin, how's it going?
I am doing great, Ben. Thank you very much for having me on. How are you today?
I'm doing really well. I'm super jazzed for today. I kid you not. What we're about to do is out of my area of expertise when it comes to web dev, and yet it leverages some core browser APIs, and so it seems very up my wheelhouse. So I'm excited to have you on. Super excited to have you show me what we're doing today. But before we do that, Austin, would you care to introduce yourself for folks who might not know who you are?
Yeah, for sure. My name is Austin Crim. I recently joined the DevRel team at Prisma, where we are making databases easy for everyone, or at least trying. I have been, let's see, in the web dev field for maybe 3 or 4 years now. So I'm still relatively new, but I'm loving it. I've had a great time getting to know some of the wonderful folks over in the React Podcast Discord. We should probably drop that link as well. But yeah, I really love the front end space. I love the web platform. I've been digging into it a lot recently. But yeah, I'm definitely free to chat. If anyone wants to reach out, love to make some new friends.
All right. Yeah, I'm going to go ahead and start, I guess, sharing my screen and we can take a look at a few things. First of all, I've already dropped Austin's Twitter in the chat. Please go follow Austin. Also, you should go read some of Austin's blog posts over at austincrim.com. And then finally, you've got this project here, Perusing the Platform. Can you kind of talk to us about what this is?
Yeah, absolutely. So Perusing the Platform was started kind of on accident, where I was on the MDN docs, the Mozilla docs, as many of us find ourselves uh, throughout the day. And I stumbled upon a page that had a list of every browser API, every web API, and I was blown away just at the amount of stuff that was out there and the amount of stuff that was already built in, just waiting to be used with vanilla JavaScript. So I had the thought of learning about some of the ones that interested me the most and writing about them as well. So that was kind of the impetus for perusing the platform, and I've had a lot of fun with it.
All right. Yeah, and so one of the APIs that you've been researching as a result of this is web audio, and you haven't written about it, but I guess as like before we even really dive into what we're doing today, can you kind of talk to us about what the web audio API is?
Yeah, the web audio API is really cool. It's a big API. There's a lot that you can do with it, and as a result, it can be a little bit intimidating to get started with it, just because there's a lot of different interfaces and objects and methods and all sorts of fun stuff. But it is really fun, and you can do a lot of cool stuff with it. You can um, do all sorts of audio processing and recording, filtering, any of those things. We're getting into some of those today. But the use cases are basically endless, which does make it a little, like I said, a little bit intimidating to get started. But we'll start with the basics today.
Okay. And so today we're building a theremin.
That's right. Yeah. I don't know. We should drop like a YouTube video or something of someone playing a theremin so
Goodness,
everyone can
yes. I
get the full effect.
I feel like I probably shouldn't be playing other YouTube videos on stream. But it is the sci-fi instrument, like the
Yeah.
intro of like Doctor Who, right? The just rising and falling tones is
Yeah.
what we'll be building. Maybe I'll drop the like Wikipedia article is what
There
I'll
you go.
do.
That's a safe one.
Yeah.
Just think like UFO vibes, and you pretty much
Yeah.
got it.
Doctor Who, X Files, you're in the right space. Yeah. Um, tons of fun stuff. It's also I think the geekiest musical instrument.
Probably, probably. Yeah, it's cool. But the main idea with it is you control um, frequency kind of on one axis, and the volume or the gain on the other axis or
Mhm.
axis. So that's the main idea, and that's what we'll be building today.
Awesome. And I guess general caveat, I did. You sent me a demo ahead of time, and I played around with it. And my cat Tuna very much so did not care for this. So, just a general warning for anyone who's listening to this at home. We are going to have rising and falling tones. So, if that's something that you find uncomfortable, or if you have pets around that that might find this uncomfortable, you may need to adjust your setup, or this might be a good stream to miss in that regard, because that is a lot of what we're going to be doing today. So, Web Audio API, as I understand it, can create audio, but it can also, and maybe we won't be diving into this so much today, but it can also intake audio. Is that correct?
Yeah, absolutely. And we can chat about this more as we get started and get into some of the more fundamental concepts. But as an example, a little app that I built a few months ago was I actually was plugging my guitar into my computer and processing the audio input from the guitar to make different effects and recordings and things like that. So yeah, like I said, there's a ton of flexibility with it, and we'll start to understand that more as we get started.
Awesome. And thank you, Thorium Sim, for dropping that link to Fireworks, which is a use case of it. Cool. So let's go ahead and get started. How should we get started, Austin?
Yeah, absolutely. So we'll start with by scaffolding out a Beat app because Beat is the hypiest technology recently, but we'll use their vanilla template. So Beat's just going to help us get started really easily, and it's a really fast build server, so we can get the audio refresh going. So we'll start off by using the create beat command or npm init beat, and we'll select the vanilla template when that option is presented to us.
Okay. And yes, thank you for providing feedback about Austin's audio in the chat. That audio is an ever persistent challenge for me, so I'm always trying to figure out how to get this right. Maybe I'll just move my microphone a little further away to see if that helps a bit. Please keep providing input on our audio as we go. Okay, so we're gonna create a project here. I'm gonna just call this the name of the stream. Web audio. Okay. And you said vanilla template.
Yep, we'll stick with the vanilla.
All right. And just vanilla, not even TypeScript.
Yeah.
Vanilla.
Yeah, we can skip TypeScript for now. Sorry, Alex.
All right. Let's take a look at what we've got here. Okay, looks like we've got ourselves a pretty simple index HTML. We've got a main file without a whole lot going on. All right, cool.
Yeah, so we're going to do most of our work in the main JavaScript file. But before we hop over there, if you want to pop open your HTML file, we'll just do a little tiny bit of setup here that'll help us get going. So we're going to want a canvas element on the screen.
Okay.
So if you wouldn't mind, you can delete that div. I don't think we need that div anymore. But if you want to give us a canvas, give it, maybe just throw a width and a height on it of 500 or something like that, just to give us a box to interact with on the screen. And to make that a little easier to see, we can hop in the CSS file as well and give the canvas just give it a border or an outline or something like that, so we can have an understanding of where we are.
Okay.
Cool. So we can also fire up the server so we can make sure that our changes are taking place. I think it's run dev, npm run dev with Vite, and that should start on 3000. Oh, we need to run npm install.
Oh, okay, got it. Not done for us, apparently.
Sorry about that. Yeah.
Just Austin.
So once that's done, we should be able to npm run dev and see our beautiful box on the screen.
Have to be very careful about how I pull this up, because otherwise Opera will open. Okay. And it looks like I'm wildly zoomed in. There we go.
Sweet. So we have a box. So that's going to be the playground for our Theremin. That's going to be the way we interact with it. So now that we've got that set up, we can hop over to our JavaScript file when you're ready, and we can start getting into the API.
Min. I'm just gonna center this.
Nope, that's great.
Display grid, place items, center. Boom. It's not going to work. Is it display flex? Is that what I need? I thought it was display grid.
Is it place content? Or place?
Oh, it might be place content. We'll see.
There's too many of those different properties with grid and flex.
Yeah. Oh well. We tried. Yeah, hang on. Let me audio is hard. Yeah, maybe move your mic a little further away from your mouth. And I think
cool.
Yeah, I think that's gonna be better at least. All right. Sorry about that, y'all. Okay, so does it hot reload CSS?
It should. Yep, it should.
Let me just try this once more with feeling. Okay. Anyway, it'll be fine. It will. Oh, you know what? I bet it doesn't have a main. I bet you. Yeah.
Yep. Good call.
Need those semantic elements, you know?
Right. Yeah.
There we go. Okay, cool. We're
Excellent.
centered. We're centered.
Excellent work. We are professional developers on this stream, so we can figure things out.
All right. So we've got a canvas. Why have we created a canvas?
So this canvas is going to be our interface into the Theremin once we get that going. As we're about to see, as we hop into our JavaScript file, the web audio API actually will not play any sound unless you have a user interaction. And this helps prevent some of the spammy websites from blasting your speakers as soon as you load a URL.
Makes sense.
So let's hop over to our JavaScript file and we can get going. So you can delete that document query selector. We won't need that. So the first and fundamental block of the web audio API is something called an audio context. So if you want to instantiate a new audio context and store that in a variable, that's kind of similar. I think of it kind of similar to how you think of a canvas context, where it's kind of your entry point into the API. It kind of does the management behind the scenes. We'll use the audio context to create other kinds of audio nodes, and it does some time tracking behind the scenes. By default, it'll help output audio to your speakers, etc. So the audio context is kind of going to be our main interaction with the audio API, and it'll help manage things for us behind the scenes.
Makes sense.
So now we have a context. We will then use this context to create other audio nodes. So in the web audio API, one of the main concepts is what are called audio nodes. So there's really three types of nodes or things that you're going to interact with in the web audio API. You'll have audio inputs. You'll have nodes in the middle that change that audio in some way, and then at the end you'll have an output.
Okay.
They call this the audio graph in web terminology, because you can have lots of different inputs, lots of different modifiers. They can all connect to each other.
Interesting.
And then you can pipe them to one or many outputs. So then the type of node that we're going to use to generate our sound, or as kind of a sound input, if you will, is called an oscillator node.
Okay.
An oscillator node generates kind of a plain, pure signal that we'll use to be our Theremin sound.
Yeah, and by playing pure signal, you're referring to like a sine wave, right? Like just straight up a boring old sine wave, a constant tone, constant frequency that we'll be able to modulate.
Yep. So the oscillator, we will set it to use a sine wave. There are a couple different other waves that you can use, like a sawtooth or a triangle wave. You might be familiar with those if you've done any synthesized music before.
Okay.
So let's create a new variable, and this will be our oscillator or oscillator node. And we'll get this oscillator node by calling our audio context variable dot create oscillator.
Okay.
And VS Code should help you out. And we won't pass any parameters into that. So now we have a new instance of an oscillator node, and this is what we interact with to set some parameters and then get some sound playing. So below that line, the oscillator node instance has a couple properties on it that we can set. So if you want to say oscillator node dot type and set that equal to a string of sine.
Is that all lowercase like this?
Yeah. Yeah.
Okay.
So this is that sine wave that you're talking about, which is basically just a smooth wave that kind of goes up and down like that. And that'll just give us a smooth plain sound.
Okay.
So below that, let's also set a frequency. So if you say oscillator.frequency, and frequency is what's called in the web audio API terminology, an audio param. And audio params have a lot of common methods that you can call on them that relate to setting their values, how you set them, and how you control them through a period of time. So what we'll actually do is oscillator node.frequency dot, and we'll call a method on the frequency. That's called set value at time. And we'll pass a couple parameters into here.
Okay.
So the first parameter is the actual value of the frequency that we want to set. And this is in hertz. Let's just set this to something like 260. I think that's close to middle C on a piano.
Okay.
And then as a second parameter is the time at which you want the frequency to be 260.
Okay. And
And
so
for
would
now-
would that be 0 to just say like at the beginning of our graph? Because I'm picturing this as like a timeline.
Right. Yeah. That's the right way to think of it.
Okay.
And there's an easier way to do that, or a more audio API-ish way to do that is by using our audio context, which actually tracks time internally. So we'll say audio context dot current time. That'll just be the time that the audio context has been tracking since it got instantiated. And this set value at time pattern is going to crop its head up multiple times as we're interacting with the API, where you're changing properties as your application is going.
Got it.
So you've hit a lot of concepts here of the web audio API, of the audio context. We're creating a sound input with the oscillator node. We're setting some different properties on it. And all of this is just kind of basic bread and butter audio API stuff that you'll get really used to as you continue to work with it. One of the things about the audio API is it does have a lot of API surface, but it does a lot of like object-oriented style inheritance, where you'll see a lot of common methods crop up on it as you work with it, and a lot of common patterns.
Okay, that makes sense.
So now that we have a node, our oscillator node, this is what I referred to as a sound input earlier, or something that's going to create sound. So the next step would be to output it.
Okay.
We'll throw some nodes in the middle and a little bit to modify the gain or the volume. But for now, let's connect our node to our audio output.
Okay.
So the oscillator instance has a method on it that's called connect. So we can say oscillator node dot connect, and this is piping the output, or this is piping the signal that the oscillator node is going to generate into where we're going to direct it, which as you see, VS Code is pointing us to pass it a destination node or another audio node. So the audio context actually comes with a destination property. So if you say audio context dot destination, this defaults to your computer's default output.
Oh dang, okay. Makes sense.
So now we've created this node, we've set some properties on it. We've actually connected it behind the scenes to our speakers, or audio context.destination. The last step would be to play the sound.
Okay.
There's a couple different ways we could do this. I'm trying to think about the best way. Let's just do the simplest way for now, and then we can make it a little bit easier as we go. So like I said, to play sound with the web audio API, you actually have to have user interaction to prevent any kind of spam or anything like that. So let's get a reference to our canvas element. So if you just want to have a new variable canvas, and if you want to do query selector or get element by ID or anything like that, just to get a reference to our canvas element. So we can put an event listener on it. So let's just have a click event where we call, yep, looks good. So now we'll call oscillator node dot start as a method, and that should actually start our sound. playing through our speakers.
Okay.
I don't know what your volume is set at right now. It shouldn't be too harsh because we've set the frequency to be a little bit lower than the default. And like I mentioned to you off stream, if something goes awry, you can always just refresh the page or close the page and it should stop the sound from playing. But if we want to flip over to the browser and try clicking and see if we get some kind of signal or output.
All right, I'm gonna click. So fair warning, y'all, tone about to happen. Oh, hang on. Unmute site. There we go.
Very cool.
All right, well, Austin, this has been an absolute pleasure. Thank you so much for joining. We've created sound. See you all next time.
That was the goal.
That was the goal. We made sound.
Very cool. So we've got the plumbing set up. We can start to do a lot of fun things now.
All right.
But first, I think I should give you a hand, Ben. That was very well done.
Thank you. Thank you.
We got the sound playing. That was one of the main goals.
All right. Accomplished.
So let's talk about a theremin now. So like I mentioned earlier, the two main ways that you interact with a theremin, you have a frequency control, which either moves your pitch up and down. And then you also have a volume control. And with a theremin, you play those with your hands by moving your hands either closer or further away to the two axes there. So with our web theremin, I figured we could have interact with it through a mouse event. So whether you mouse across the box or across the canvas would be, let's call that frequency. And then whether you mouse up or down will be the volume or the gain.
Makes sense.
And with the code we've already written, we've actually got all the building blocks already to be able to do this. We just need to wire up some of the event listeners and pass in the correct parameters. So you can already imagine that as we mouse over, we're going to change the frequency on our oscillator node, and we're going to do it in the exact same way that we did it on line 8, and we'll just pass in the relevant parameters. So yeah, we can add an event listener on the canvas, have a mouse move event.
Okay.
We'll need a reference to that event as well in the callback that you pass, so we can get the coordinates.
Okay.
So when we mouse over the canvas, we want to increase or decrease the frequency based on where our mouse is. So we can again call that oscillator node.frequency.setValue at time. And then that first parameter will just pass the X position of where the cursor is. So we can call event.offsetX, which will give us the X coordinates relative to where the canvas is at.
Very cool.
If we think about it a little bit, we set up our canvas to have, I think we said 500 by 500. So at the very left side of the canvas, that'll set the frequency to 0, and the very right side will be 500, which seems like relatively reasonable parameters for the stream. We shouldn't be blowing our eardrums out or anything with any high-pitched
I'm gonna give it a shot.
Squeaking. So yeah, let's give it a shot and see if we can get that to go.
All right, so I'm starting in the middle, so it's gonna be about that 250, 260 mark.
Yeah. Uh-oh.
I'm not getting any change.
Interesting. Do we have anything in the console?
Ooh, let's check.
We didn't pass this the second parameter, did we? So this is we want to set value at time.
Oh, okay.
So the time part actually is important. Sorry, I forgot that. So then again, you can just pass the audio context at current time, and that will get things set up at the right time for us.
Got it. Let's try this again.
Very cool. That's very satisfying.
It is. That's fun. That's fun. We're already getting bleeps and bloops. I'm already well on my way towards getting hired for Foley work in the next Star Wars movie.
Yes, exactly.
And folks in the chat are now asking for a theremin command, which I'll have to figure out how to make that work, huh? All right.
Next project.
And I imagine, so it's not that much of a stretch to say that we're probably going to be doing something similar with our gain, just on the vertical axis.
Absolutely. So we'll first need to create a new gain node.
Okay.
Which will be, very similar to how we did on line 6 with the oscillator node. So we can just have a new variable gain node, and that'll also be just created with audio context.create gain.
And does this take any arguments?
That doesn't take any parameters.
Okay.
No SAMs. Then below that, we can just set a default gain. So we can say gain node dot gain. And then very similar to the frequency, that'll be a dot set value at time.
Oh, I see.
Because a gain node technically inherits from audio param, which all have the same methods on it. So we'll set this to like 0.3. I think gain is like a value from 0 to, I don't actually know what the max is, but 0.3 seems like a reasonable place to start. And again, yep, we'll just pass the current time.
Okay.
So then in our mouse move, actually before we go there, let's talk about our audio graph again. So on line 9, we're connecting our oscillator node, or the thing that's generating our audio, directly to the speakers. So if we left it like this, we would totally skip our gain node and it wouldn't actually have any effect. So this is where that kind of piping concept comes into play, and where the Web Audio API offers a lot of flexibility. So if you think about it in your mental model, we want to generate the sound, then we want to process it through our gain node, then we want to send it to the speakers.
Okay.
And you can model that exactly like I said it. So you can say oscillator node.connect, and then we pass in our gain node instead of going straight to the destination. As our gain node. Okay, and then we'll need to actually need to delete line 9 now.
Okay.
So then we're going from oscillator node connect to the gain node.
Oh,
you can actually just,
and then would it be gain node dot connect audio? Okay, got it.
Exactly. Exactly.
Dot destination.
Dot destination. Yep. Exactly. So now we're going oscillator to gain out to the speakers. That's exactly right.
Very cool. Okay, that seems like I never would have guessed that, but now it seems very intuitive. Awesome.
Right. Yeah. I was in the same boat when I started learning, but it is actually kind of an intuitive idea once you step back and think about it a little bit, so that you can have, you could imagine having several different processor nodes in the middle before you send it to an output. You can imagine sending it to multiple outputs. Maybe you wanted to send it through the speakers, but also record. A couple different ways you could do that. But yeah, so now we have our oscillator node generating the sound.
Okay.
We're sending it into the gain node. That's going to process it at that 0.3 gain that we set above, and we're sending it straight to the speaker. So now if you tested it out, it should be a little bit quieter, but we haven't yet implemented that dynamic part of it.
Okay, it is, I think, quieter. Hard to, I forget my frame of reference, but that makes sense.
Yeah.
Whoa.
Yeah.
Hang on. Okay, so I don't even have to refresh anymore if I just go far left, because that puts the frequency at 0.
Right, yeah,
nice.
That puts it at 0, yeah.
Nice.
That makes sense.
Okay.
Cool. So now, very similar to what we did with the frequency mouse move, we'll just need to flip it and use the y-axis instead. So we'll set the gain value at time.
And
you can pass it dot offset y.
And audio context dot current time. Nice.
Yep.
Getting the hang of this, Austin.
Yes, you are nailing it. So yeah, go ahead and play with it.
Wait. No, this is gonna bring us from 0 to 500, right?
Yes. So the way we have it set up now, actually, mouse at the bottom will be the loudest, and mouse at the top will be the quietest. Since y gets measured from the top left.
Oh, right. Okay.
Or from the top of the box. So then top would be 0, bottom would be 500, and that seems actually really loud. We probably shouldn't do that.
Yeah. Let's try very carefully up at the top. Just.
Oh, interesting.
Oh, it's not doing.
Maybe it's hitting some kind of max.
It could be. Yeah. Maybe it needs to be. You said it's from like 0 to 1, right? Like most likely.
I don't actually know what the max is. If anyone else in the chat, that'd be great to know. But what I actually, that's a great way to do it, to just kind of take that scale down a little bit so that every pixel you're moving, it's only actually increasing it by a fraction of that. That's a good way to do it.
Are we sure we've done this right? Is gain set value at time? I'm not. Maybe it's just my browser being weird, but
that's interesting. So what's the? It's really quiet on the Zoom call. What's actually happening? Like, what's the behavior?
As I move it up and down, I'm not noticing any change to the volume here.
Okay. Interesting. It definitely looks like we have it set up right.
Let's check the dev tools. Where have those been hidden? They've been hidden here. Stop. Okay. Console. Oh wait. Cannot read properties of undefined. Reading set value at time on line 20. That's almost definitely our... Yeah, it's our gain. Is it actually called gain?
Wait. So on line 20, you want to select the gain node.gain. We have it as oscillator node.gain.
Oh, okay. Cool.
Sweet. Thank you, DevTools.
Thank you, DevTools. All right. And then let me shut down those DevTools just because that, I don't know, I feel like that always messes with my like live reloading. Yeah, that works.
Very cool. Yeah, it's still coming across kind of quiet on my end, but I trust you. Okay. That's excellent. So if we wanted to, actually flip it so that the bottom is the quietest, and the top is the loudest, you could actually do your calculation, but subtract it from the canvas height. So you could say canvas, either flip it or do canvas height minus.
Oh, I see.
That calculation, which would, as you move up, it would go higher. I think, if my math is correct.
That is too much fun. You can make little loop-de-loops.
Yeah, after I built this demo, I definitely played with it for a long time, trying to, pretending like I was in a UFO or something.
Yeah, and chat's loving this as well. We got Chan over here. I'm laughing with joy right now. Ooh, we do need a web audio API storybook plugin. I have no idea what that would look like, but we do need it. Needs to be done. This is incredible. I apologize to everyone's pets.
Yeah, so that's great. And this is a fun little demo because it touches a lot of the base concepts of the web audio API, but in a way that, like you said, it's a lot of fun, and it's not, we've only written 20 lines of code or something like that. So you can see the power and flexibility of the web audio API, and just in a simple use case like this, there's a couple different places we can take it if we wanted to just polish off some of the rough edges as well. Or is there anything that you're particularly interested in, Ben, that you'd like to see?
What kind of polish were you thinking of? And is there anything you've got like that could be a quick demo to like learn more of the API?
Yeah, so there's I'm gonna throw a link in the chat that is a list of all the different nodes and the different audio effects that you can apply with the web audio API.
Okay.
We could implement like a play pause type of interface, or we could give our canvas labels that will update with the values. There's a couple different places we could go.
All right. Chat, what kinds of things would you like to see? Where should we take this next? Well, we've got Austin hostage. Give them some time to respond. Because Twitch delays are always fun.
Oh yeah, Anthony's got a good idea of using the other waveforms, like the other oscillator types. So we use the sine wave, if you remember. But I think, will VS Code give you autocomplete if you try and assign something to oscillator type?
Let's see. Doesn't
Bummer.
seem like it. Yeah, no. Oh, hey, there we go. Yes. Custom
Oh, cool.
sawtooth, sine, square, or triangle. We gotta do
Yeah, so
sawtooth, right? That sounds rad.
yeah,
We gotta.
it does sound the coolest out of all of them. Like the name of it sounds the coolest.
Yeah. Okay. Let's see. Let's see how that changes things. Nope. Abort. 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 We are not doing that. We can't. We can't.
It's definitely the most brash sounding, the most offensive to the ear.
Oh God. Sorry, Tuna. Sorry,
I think
friend.
I think I think square and triangle are a little bit less in your face.
Okay. Let's do a square wave. And then I think it would be fun though to experiment with what Chan's saying with like handling the waveforms with like keyboard controls. That could be a fun place to take this too. Um, let's see. So, hey, do
Still
the
pretty harsh.
yeah, do the different waves have different metrics for gain?
That's a great question. I don't know enough audio science to answer that.
Oh wait. Oh, you know what it is. I keep forgetting that max volume is now at the top. There we go.
That's a little bit nicer.
Okay. Cool. All right. Yeah, so maybe we do something to I don't know, what polish would you think would be the most interesting, Austin?
So let's do like let's just implement like the play, pause, or like mute, unmute
Yeah.
really quick, because that's just a handful of lines of code and it might be kind of useful if we start messing in uncharted territory.
Sounds good. Yeah, let's handle the
Um,
play pause.
so there's actually, the easiest way to do it is to actually use the audio context that we created.
Okay.
It has an overarching um, internal state of whether the audio context is like basically playing or if it's not playing. So uh, in our on click, we can actually just add. We'll actually remove. Well, let's see, how should we do this? Let's move the oscillator node.start outside of the event listener. Let's just put it like with the other, maybe just put it like after line 8 or something.
Line
So we're
8.
actually going to start it, but the audio context won't play it until we interact.
Got it.
Or no sound will actually be output until we interact. So let's add an if statement here. And it's basically just going to be a simple toggle. So we'll look at our audio context variable dot state, and we'll check if this is equal to, so that's a property, and we'll check if that's equal to suspended.
Okay.
And if it is suspended and we click, then we want to start playing. So we can say audio context dot resume is the method. And then in an else branch, if it's not suspended, we can call audio context dot suspend.
Okay.
And that should in effect start playing it. If it's already playing, it'll mute it and it won't come out of our speakers anymore.
Got it. Let's give this a shot real quick. Yeah. Nice.
It gives you a little more control when we start blowing up everyone's eardrums.
Okay. Always down for a little more control in that regard. Adrian over here. Can y'all simmer down? This is some antics, not some physics. Sorry, we're doing the antics of physics now. That's just what we are now. I'm pivoting. I'm following what Anthony's suggesting. I'm becoming the next Dan Deacon. This is my new career. Okay.
Very cool.
Yeah. So, what next?
That is a great question. There's definitely elements where you could get into some keyboard control, like Chan mentioned, of like you could assign like the different waveforms to different keys on the keyboard. That would be pretty straightforward. I unfortunately don't know a ton about the other I've used some of the other audio nodes.
Okay.
I don't know a ton about them as much as I do just the basic ones. But there's a whole world within like the effects, in the world of like audio effects that you can definitely cook up with the different audio nodes.
Yeah. So what you okay? So the nodes, remind me, those are ways we modify the sound in which we're making, right? So our oscillator, which is the kind of wave that this is, that's a node, like that modifies the sound. The gain is a node, it modifies the sound specifically volume wise. I'm just gonna quickly take a look and see, is there a good list of nodes in here?
Yeah, so there's a heading defining audio effects filters.
Okay.
Those are the list of nodes that like kind of modify sound as it comes in and sends it out.
Gotcha.
But like I said, yeah, I unfortunately don't have a ton of experience with these other ones.
Then in that case, let's add maybe a way to like set the wave type with the keyboard. I think that would be a good demo to kind of see us through to the rest of the stream, perhaps.
Yeah.
Cool.
Yeah, so hopefully it should be as simple as adding some keyboard events, some global keyboard event listeners, and assigning the oscillator node.type. The thing that I don't know, which is going to be interesting to find out, is when you reassign the oscillator node type while it's playing, if it'll actually switch it live or if you'll have to do some kind of reset. So that should be interesting to find out.
All right, switch on event key. I'm gonna say case. Should we use numbers, you think?
Sure. Yeah. Just do like 1, 2, 3, 4.
Yeah. Okay. Then in that case, if you hit 1, oscillator node dot type equals custom worries me.
Yeah, custom's a little more involved.
Let's maybe not do custom unless you feel very confident in it.
Yeah, we can skip that one.
Skip sign? Oh, skip
Sorry,
custom.
No, skip custom, yeah.
Got it. Square, and then the last one was triangle. And then I think default, it's like return, perhaps. Okay.
Sure.
Oh god. Why? God. Okay. That was oh, key events. Okay. Key events are interactions, but that feels bad. Okay.
That makes sense.
I'm hitting the keys and it's changing.
Really? That's awesome.
Nice. Okay.
Very cool.
Okay.
That was easier than I thought it was going to be, actually. I didn't think that was going to work on the first try.
Goodness. Okay, so let's maybe polish up this demo a bit. I guess step away from the audio API and figure out like how to make this into like a Theremin app that people could actually like use intuitively. So maybe let's have some like dynamic labels and such.
Yeah, that sounds great. Again, that should be it shouldn't be a huge lift to do that. We'll just have to get a couple labels in the HTML.
Okay.
And then on our mouse move events, just make sure that we update those, as well as the different values. So I don't know if there's like a good semantic tag other than paragraph or something to use for this, but
probably paragraph. Okay.
That should be, so we could also have one for the frequency and one for the gain.
You know what? We're using a DL. We're using a DL.
There we go. That's the Ben I know right there.
I've been activated. In case you don't know what the element here is, I've just put my blog post in the chat. All right, we're gonna use. All right, it's gonna be a DT for the gain, and then ID equals gain, and then we're gonna have frequency. Oops. it's going to be frequency. And then finally, we have waveform and waveform. God, okay. Okay, how do we make it not do it like when I saved? Good God.
It's interesting.
What?
So it just happens right when you refresh.
Yeah, I'm gonna
Wait,
uncomment
that's
or I'm gonna comment that.
Yeah, that's fine.
Okay, I don't. That doesn't seem to do it. Is there a?
You could.
Oh, you know
could
what?
change the default type to sine, so it's not so abrasive if you want as well on line 7.
That would be a good call. Yes. Sign, and we're just gonna immediately suspend. I think that's what we're gonna do.
Good move.
Nope. That turns out does not work.
Really? Oh, you want to call audio context.suspend on line 10.
Okay, got it. Nope. That's not it. Okay. There we go. Got it. Cool. That's nicer. All right. Yeah, let's
It's a much softer sound, yeah.
Yeah. All right. So we've got our elements here. And then yeah, so let's go ahead and set in our mouse move. We're gonna actually make this let new frequency equals.
Yep. I like where you're going.
I guess I don't really need to do that, but let new gain equals, and then here we will definitely outsource this. So this is new gain. This is new frequency. And then we need to also populate some nodes. So let me just grab those real quick. Const gain readout. Selector. Get me that gain. Frequency readout. Frequency. And then finally, waveform readout. That's going to be waveform. Okay. And then we're going to do frequency readout dot inner. Okay, it's just going to be HTML. Equals new frequency. And same for gain readout is new gain. And we'll handle updating the waveform soon. Sweet.
Very cool.
All right.
That sound is so fun. It doesn't get old.
It doesn't. You know, new semantic intro music, perhaps?
Yeah.
You know, you show it for a stream, like, looking to learn some web dev, and you enter, like, eerie British sci-fi music.
We're in the X-Files all of a sudden.
Incredible. Okay. And then this is going to be waveform readout. Inner HTML is sawtooth. And then I'll just copy this throughout. Nope. That won't do. This'll do. Hey Ben, how do you audio synthesize a fart sound?
That's great. Awesome.
Yep.
Well
and
done.
we start off with this will start off as sign. It's not the world's like prettiest visualization to start, but
it gets the job done.
It gets the job done.
We definitely need to share this demo when we're done, and everyone needs to go play with it just to experience the satisfaction of
Yeah,
playing with Theremin.
let's get this deployed. Let's get this deployed. Get in it. Boom.
Great
Yeah.
idea.
Boom. Make a freaking theremin. Boom. Who says you need conventional commits? This is right. This is correct.
Yes.
Yes. How do I deploy a Vite app? What's the best way to do that?
That's it should be, since we just have an HTML file and a CSS file and a JavaScript file. I think we can just run build and then deploy whatever the output is of that.
Got it.
The only reason we'd have to run a build is because I think we're importing our CSS file in our JavaScript file. So that would need to be handled with the Vite's build process. If we wanted to skirt around that, we could just straight up deploy the 3 files. Otherwise, we can, just do that build and get that folder deployed.
Nice. Okay, so I have here, it is holding on to that for me. Okay, so I've got this dist with assets and stuff. All right, and I can just like click and drag that to Netlify. Let's go ahead and do that. Let me. Oh, you know what we're gonna do? We're gonna open up Opera. All right. Let's see. There we go. Shut that down. Open up my Opera dashboard here. And then I think the easiest thing to do here is open this up in my Finder. And click and drag this. Yeah, here we go. Boom.
That's such a smooth feature from Netlify, by the way.
It really is. Let's give it a better name, perhaps. Change site name. Here we go. Semantics Theremin. Boom. Should be up now. It's up. So, y'all, go play with that Theremin.
Go make some music.
What a smooth deployment. Sorry, I'm gonna wax poetic here. Web development is cool. Like, what a smooth deployment experience that was for something like this. Like, every step of this has been fairly, like, just fairly nice.
Yeah, absolutely. We made a Theremin with JavaScript and got it on the internet in under an hour.
We sure did.
It's a wonderful thing.
All right.
But I've got a question for you, Ben.
Yeah.
That just came to my mind. We're not going to solve it in the last 8 minutes, but if we wanted to support something like this with keyboard interactions, what do you think that would look like?
That's a good question. I kind of feel okay. I kind of feel like the step one is. Man, I almost feel like the trick here is to trick the browser or trick assistive technology into thinking that the canvas is a button. So I almost, and I know I advise against like clickable divs and turning things that aren't buttons into buttons, but I kind of feel like where I would start is here. So what this does is the tab index says, hey, this is focusable. It enters the DOM order, like the DOM focus order, so you can tab to it. And then roll button means that when an assistive technology receives this canvas, it's actually going to think that it's a button, so it's going to announce that as such. It's going to say that every ARIA button needs an accessible name. That's totally fine. So I'm going to break this out into multiple lines, perhaps. And to give it an accessible name, I'm going to use ARIA label. Let me put in another blog post in case you were curious what it is I'm doing here, why we need ARIA label, what that's doing for us. There you go. And I'm gonna, I think for my label, make this click to play, or actually maybe press to play or pause. And then the next key thing would be adding we're not gonna solve this here, but adding like arrow key support, I think, would be the best way to like move up and down, perhaps.
Yes. Yeah.
I think.
Yeah, it'd be interesting to get have some kind of visual indicator on the canvas
Yeah.
that you could control with your arrow keys. That's really interesting. I've never thought about like what the accessibility story looks like for a Canvas element, like keyboard support, things like that. I've never done something like that, but that would be a really interesting place to take this next.
Yeah, and now that I'm thinking about this might not actually be a good case for role equals button, but maybe role equals application, which is a thing I have zero experience with. But it usually
Interesting. I've never heard of that.
from what I understand, it defines like, I mean, really a full application, but something that owns its own keyboard behavior. Um,
Cool.
so I think that while I know next to nothing about this, I think that might be a good use case for this for this role.
Yeah.
You would likely need to add some extra details to like announce what all the keys are that you can do and stuff like that. But
interesting.
yeah, I think that would be a uh, a good follow up to try with this, perhaps.
Yeah, that'd be a fun problem, and I think like it's got to be possible somehow. Like people make video games or whatever using the canvas, so I'm sure people have run into this issue in the past. But yeah, I hadn't really thought about that before.
Yeah, could definitely be fun to play around with. I think if you're gonna play around with this, right, please do not like do not take my word as gospel here. The most important thing would be to perform user testing with like people who would actually need that keyboard navigability. So, but could be a fun thing to play around with, perhaps.
Yeah, very interesting.
Austin, it has been fantastic having you on. Thank you so much for joining us and for building just something delightful. You know, I kind of want to like just go back and keep playing with our theremin. That's so fun. So thank you so much for joining us, y'all. Go check out Austin all the places: twitter.com/crim_codes, austincrim.com, and perusing the platform. Are you going to be writing anything about the web audio API for perusing the platform soon?
I am. Yep. Web audio is next on my list for perusing the platform for sure. So keep an eye out. But thank you very much, Ben. It's been a lot of fun. So I really appreciate you letting me come on and play around. And I hope you had as much fun as I did.
Oh, I certainly did. It's a fun toy to have built. Y'all, thank you so much for joining. Stick around. We are going to figure out someone good to raid. But just so you know, I'm starting my new job next week. So I'm entering like a vacation mode. This is going to be the last stream for a bit. And I don't necessarily know when the next stream is going to be. So follow at Semantics Dev on Twitter, and they'll help you keep up to date with the next streams whenever those happen. So thank you all for being here. Austin, thank you one more time for joining. This has been a blast, and chat, I hope you had as much fun as we did. Bye, y'all.
Thanks, everyone.